Hello everyone. This lesson we're going to talk about instrument transformer in three-phase circuit. Here's a picture showing you three potential transformer try to measure the phase voltage in this three-phase circuit. The primary side of each potential transformer is connected between one of the line to the neutral, so it's measuring the phase voltage. The secondary side, we use the step down for this potential transformer to indicating a voltage for the phase voltage. Normally, for standard potential transformer, the secondary output is usually 120 volts. This picture showing you three potential transformer is measuring the line voltage. So you can see the primary side of those potential transformer is connected between two of the lines. So output for this potential transformer on the secondary side going to indicating what's measuring the line voltage on the primary side. This picture showing you three current transformer, each is wired in one of the three-phase line to measuring the line current. This is a real weird situation because these three current transformer is actually measuring the phase current. Normally, we use current transformer to measure the line current, but in this case, here's the three delta connected three-phase delta load, and those current transformer, the wiring in each phase try to measure the phase current. In three-phase, we're talking about we can use 2 wattmeter to measuring the three-phase power as long as we connect them right. The current coil in the wattmeter, we're measuring the line current on two of the lines. The potential coil is measuring the line voltage between any of the two lines. And for three-phase power measuring by use 2 wattmeter, if the power factor of the load is at 100%, then the 2 wattmeter will have an equal reading. The total power will be the 2 wattmeters reading add up. If the power factor of the load is above 50 but below 100%, the 2 wattmeter will have different readings, but the total power still equal to the 2 wattmeters reading add up. If the power factor of the load is exactly at 50%, then one of the wattmeter going to read 0 watts, another wattmeter going to read the total power for the three-phase circuit. If somehow the power factor of the circuit is below 50%, then one of the wattmeter going to give you negative reading, one of the wattmeter still going to have positive reading. Because if we're using analog wattmeter, they cannot take negative reading, so we have to reverse the leads on that wattmeter to get a positive reading. The total power for the circuit will be the one wattmeter reading subtract another wattmeter reading. And it's always the large wattmeter's reading subtract the smallest wattmeter reading. This picture showing you we use current transformer in a three-phase motor. So in case this is a very large three-phase motor, let's say a 200 horsepower. So the overload protection, the overload heater for a 200 horsepower motor will be very big and very bulky. It's going to occupy lots of space. So if we put a current transformer in there to reduce the current to a fairly small value, then we can use pretty smaller overload heater down there. We still can providing the protection for this 200 horsepower motor by using a smaller overload heater with overload relay protection. In three-phase, we're talking about use 3 lamps to indicating ground fault in an ungrounded delta system. But there's a slightly problem with this lamp indicating, because if one of the line ground, then 2 of the lamp will become brighter, but one of the lamp will become dark. Then we always have to have someone to watch those lamps to see if a ground fault happens. So we'd like to put a ground fault detection relay in there, so the relay can send out alarm signal. So let's say have a bell or horn going on, so we know there's a ground fault happening in the circuit right when the ground fault happens. So here the circuit for ground fault alarm relay in there. The primary of 3 potential transformer is in a Y connection. The common point is connected to the ground. So when there is no ground fault in the circuit, all 3 potential transformer, the primary side, going to reduce the line voltage to a phase voltage in the Y system. The secondary side of those 3 potential transformer is delta connected, and each lamp is connected across each potential transformer, the secondary side, the terminals. So when everything working normal, all those 3 potential transformers have voltage drop across them. They're going to have a secondary voltage. 3 lamps going to come on at equal amount of voltage, so they're going to come at a certain amount of brightness. The alarm relay is connected in the way for those 3 potential transformers in the delta closure test way. So when 3 potential transformers, they all have equal amount of voltage on the secondary side, this alarm relay going to say 0 volts because the closure test for normally wired delta going to be 0. But if one of the line grounded, so there's a connection between this line to the grounding point on the primary side, the Y point. So one of the potential transformer will receive 0 volts on the primary side, but another 2 going to say the line voltage crossing. Because now they say the line voltage, the secondary side, the voltage is going to be increased √3 higher. That 2 lamp going to become brighter, but the one grounded, the lamp going to be off. Now the secondary side will become open delta connected. When they are open delta connected, the alarm relay going to say the secondary line voltage. So once the alarm relay say the secondary line voltage, they're going to send the alarm signal to sound to indicating there's a ground fault happening in the circuit. So here's a few slides with showing you the instrumentation transformer used in 3-phase circuit. If you have any question, you can send us an email or connect us online.